Have you ever imagined walking down the street and noticing the asphalt rising and falling as if it were breathing? Or what about seeing a sea of gray mud swallow entire villages, continuing unabated for decades? Our planet may seem solid, but the truth is that it is changing shape right beneath our feet in astonishing ways. In today's video, we're going to explore the world's most unstable and dangerous places, from Iceland's underground secrets to a massive city that is sinking rapidly. Go ahead and hit the like button and subscribe to the channel so you don't miss a thing. Let's get started. 8. The breathing ground of Grindavik, Iceland. Imagine for a second that the solid ground beneath your sneakers isn't solid at all. Instead, picture it as the rubbery skin of a massive balloon being pumped with air from the very center of the Earth. That is the exact nightmare 3,800 residents of this small fishing village, located about 31 miles outside of Reykjavik, faced back in November of 2023. It was not your average tremor, it was the terrifying opening act of a massive subterranean makeover, packing your entire life into a suitcase in a panic. Knowing the world is literally splitting open beneath your house is a level of anxiety most people cannot even fathom. By the time 2024 and 2025 rolled around, scientists were looking at far more than just the obvious bright red lava streams. The real mind-blowing part was watching the asphalt split apart like a loaf of bread cut right down the middle. You see, Iceland sits directly on top of the mid-Atlantic ridge. Picture two gigantic tectonic jigsaw pieces, the North American plate and the Eurasian plate, pulling away from each other at a rate of about 0.79 inches every single year. To us, that speed is completely invisible, but in the grand scheme of geology, it is a sprinting pace. It is a living, unstoppable process. As these plates drift apart, they leave a massive void. And guess what happens? Magma rushes upward to fill the empty space, cooking up brand new crust. It is absolutely wild. The landscape is warping so fast that the standard satellite maps we rely on every day become obsolete almost instantly due to the sheer scale of the ground deformation. But here is the inside scoop that most casual documentaries completely gloss over. Magma does not always shoot straight up like the baking soda volcanoes you built in middle school. In this region, the liquid rock moves sideways, carving out massive underground superhighways of pure fire. When that molten river surged directly underneath local neighborhoods, it warped the surface. But as it kept moving out toward the ocean, it left a massive empty pocket behind. The ground did not burst from an upward push. It collapsed because it completely lost its structural support after that invisible river passed through. Geologists call this specific type of structural drop a graben, and it is the exact reason why houses tore completely apart from the foundation all the way to the roof. It is a brutal reminder of just how tiny we are. This entire peninsula slept for 800 years before waking up in 2021, and computer models suggest this active cycle is going to last for decades. Moving back here is a heartbreaking gamble where human nostalgia goes toe-to-toe with the unyielding laws of physics. 7. The Sidoarjo mud volcano, East Java, Indonesia. Think about opening a giant 2-liter bottle of soda that has been shaken up with extreme force. No matter how hard you twist the cap back on, the sticky liquid just keeps spraying out. Now imagine it keeps spraying for decades. That is precisely what has been going on out here since May 29, 2006. This was not your classic Hollywood volcanic explosion with flying rocks and rivers of glowing lava. Not even close. Instead, a relentless, thick, warm torrent of grayish mud erupted, seemingly connected to an endless supply deep underground. 20 years have flown by since that initial rupture, and the Earth is still spitting out roughly 100,000 cubic meters of this clay-heavy sludge every 24 hours. Try to wrap your head around that volume for a moment. That is enough mud to fill dozens of Olympic-sized swimming pools every single day. While the physics of this phenomenon are deeply fascinating, the blame game behind it sparked a massive scientific and legal battle. On one side of the courtroom, top-tier experts point the finger at a gas exploration company that was drilling a deep well just over 200 yards from the exact spot where the mud first broke through. The leading theory is that the drill bit punctured a hyper-pressurized underground reservoir, shattering the natural rock seal that kept the whole system under lock and key. On the flip side, the corporation blamed a magnitude 6.3 earthquake that struck Central Java just 2 days prior. The local courts ended up siding with the earthquake theory, though plenty of independent analysts view that verdict with serious skepticism due to corporate backroom deals. The usual story, right? But the thing that really keeps me up at night is how this material behaves on a thermodynamic level. This site operates like a perfect self-sustaining thermodynamic kitchen. The mud is not just shooting out due to simple mechanical pressure built up at the bottom. The real scientific secret is that boiling groundwater is constantly mixing with deep layers of shale, which is a rock packed with soft clay. As this rock gets cooked by intense geothermal activity, it chemically breaks down and releases a staggering amount of gas. These gases expand the volume of the mud exponentially inside the volcanic chimney, acting like a perpetual motion engine. It is a non-stop loop. The water dissolves the stone, creates gas, and that very gas shoves more mud up to the surface, carving out new microscopic pathways if anyone tries to plug the main vent. Looking at the surrounding area, the landscape was completely rewritten. The gray sludge advanced like a slow-motion tidal wave, swallowing 12 entire villages and turning thriving agricultural zones into a desolate wasteland. This forced roughly 40,000 people to pack up and relocate, spending years living in cramped temporary shelters. 6. Centralia, Pennsylvania. Imagine walking down your street and suddenly the soles of your shoes feel as hot as a boiling pot lid. As crazy as that sounds, it is real life out here. Most people assume Centralia was wiped out by a roaring forest fire, but the true silent culprit was the physical geology of the region. Back in 1962, this tiny town of 1,000 residents made the fatal mistake of organizing a routine trash burn at the local landfill. They had no idea the dump was sitting right on top of a massive vein of anthracite, an ultra-dense type of coal that essentially acts as a near-infinite thermal battery. The leftover heat from that garbage fire ignited the underground coal seam, spreading through an invisible labyrinthine network of interconnected mining tunnels that is still burning bright today, more than 60 years later. And here is the coolest scientific twist. This underground combustion does not need massive gusts of wind to survive. The ground literally breathes through micro-fissures, slowly drawing in oxygen and maintaining temperatures that skyrocket past 900 degrees Fahrenheit in certain hotspots. The toxic gas venting out, a heavy, lethal cocktail of carbon monoxide and sulfur dioxide, completely mutated the environment. During the winter, the view is both hypnotic and deeply eerie. The scalding gas hits the freezing winter air, creating massive pillars of steam that burst straight out of the cracked asphalt of Route 61, a highway that became totally warped by the structural failure of the shifting Earth. But here is the detail that almost nobody talks about. The real secret behind the longevity of this underground inferno is not just the coal itself, it is the groundwater. Rainwater soaking into the earth does not put the fire out. Instead, it triggers an intense thermochemical reaction that expands the gases and fractures the overhead rock layers, creating brand new ventilation chimneys that feed the fire more oxygen. The federal government stepped in and relocated almost the entire population in the 1980s, but 5 residents won the legal right to stay there until the end of their days. Now, they watch nature aggressively reclaim the empty streets, while a perfectly maintained church still stands watch over the disaster zone. 5. The shrinking megacity. Think about storing a heavy birthday cake inside a damp cardboard box. At first, everything looks fine, but over time, the moisture weakens the base, and the walls buckle under the weight. That is the exact crisis hitting Mexico City, which is sinking at a staggering rate of nearly 20 inches per year in its worst affected districts. This rapid deformation makes it a total outlier and a premier case study for global structural engineering. You see, the foundation here is not solid bedrock. It is soft, highly compressible clay, fine sediments that soak up moisture like a giant sponge. The Aztecs originally founded Tenochtitlan on an island in the middle of a lake back in 1325, but after 1521, the Spanish conquistadors drained the water network. Today, a massive metro area of 21 million people pumps 70% of its clean water supply straight out of deep underground aquifers. As that liquid is sucked away, the clay loses its hydrostatic support and collapses under its own immense weight. The physics are mind-boggling. The Palace of Fine Arts, which opened in 1934 and was built using heavy marble, has already dropped over 6 feet. You used to walk in right from the street level, but now you have to walk down a flight of stairs. The Metropolitan Cathedral has a highly visible tilt because the ground is giving way unevenly. Sewage pipes snap on a daily basis, and the city streets look like a roller coaster track. The nightmare scenario is not just the vertical drop, it is a phenomenon known as secondary consolidation. Even if we completely stop pumping water out of the ground today, the molecular structure of the clay has already been permanently altered. The soil will continue to compact from pure gravitational force for the next 150 years due to the massive weight of modern skyscrapers, a variable that current mathematical models are only just beginning to map accurately. It is a monumental engineering catch-22. Because cutting off the water supply means leaving one of the most vibrant capitals on Earth completely parched. The asphalt giant keeps sinking into the ancient mud of the past. 4. The amphibious exodus of Jakarta, Indonesia. It is wild to think that the weight of the morning water you use to brush your teeth could quite literally swallow your entire neighborhood. But that is the reality playing out right now in this massive metropolis of over 10 million permanent residents. Actually, if you count the surrounding urban sprawl, we are talking about 35 million people living on borrowed time. This sprawling concrete jungle is sinking so fast that parts of North Jakarta have plummeted up to 13 feet in just 2 decades. Residents find themselves walking down streets that sit well below the waves of the Java Sea, trusting their lives to a thick concrete seawall that is already cracking under the immense pressure. The core issue here is that the public utility pipeline network is a complete disaster, failing to reach even half of the population. Because of this, everyone from the low-income homeowner to the high-rise luxury hotel with a massive swimming pool drills illegal wells to suck water directly from the underground aquifer. When you drain those natural subterranean storage tanks, the earth above loses its hydraulic cushion and collapses. The crisis reached such a desperate tipping point that the government made a move straight out of a Hollywood sci-fi movie. They decided to move the entire capital city 1,200 miles away to a brand new city built from scratch called Nusantara, located in the wild jungles of Borneo. It is a mega project estimated to cost over $35 billion, and it is moving forward under a cloud of doubt. The underlying danger is no longer just the sinking ground, but the silent collapse of the natural drainage system caused by the sheer weight of the city skyscrapers. As the ground compacts violently, the 13 rivers running through the region have completely lost the natural downward slope they needed to carry water out to the open sea. Nowadays, during heavy downpours, the rivers do not flow forward. Instead, the water pools up and runs backward right into the middle of residential neighborhoods because the ground in the center of the city is now lower than the river mouths at the coast. It is a perfect hydrological trap created by our own engineering, a maze where stormwater cannot find an exit, accelerating the sinking process exponentially. Simple physics proves that just stopping the water wells will not fix it. The physical footprint of the city has rewritten the rules of water flow forever. 3. The sunken enigma of Venice, Italy. Have you ever stopped to think about how ridiculous it is to build a world-class architectural masterpiece on top of what is essentially mud jelly? Over 1,500 years ago, some brilliant minds decided to drive millions of wooden stakes deep into the floor of a muddy lagoon in northeastern Italy to support massive stone churches and palaces. The craziest part? It actually worked for a really long time. But here is the raw physics of the situation. The ground is compacting under that monumental weight, and the Adriatic Sea is aggressively claiming its territory. Over the last century, the city has dropped about 9 inches. While that might not sound like much, remember that Venice sits right at sea level. Pumping out groundwater made the situation way worse until the government banned the practice in the 1970s, but by then, the structural damage was totally irreversible. Today, the city drops between 1 and 2 millimeters a year. But when you factor in that the sea level is rising another 2.5 millimeters annually due to climate change, you get a destructive cocktail of nearly 5 millimeters of lost ground every 12 months. The famous phenomenon known as the Aqua Alta, which used to be a rare winter event that flooded St. Mark's Square, now happens roughly 250 times a year. Imagine having to walk on elevated wooden boardwalks just to go buy a loaf of bread, or watching salt water slowly rot the ground floor of your home day after day. To stop the bleeding, $7 billion was poured into the MOSE project, an incredibly complex system of 78 mobile floodgates that inflate with compressed air to block incoming tides. Between October of 2023 and April of 2024, they had to activate it 31 times. That is once every 6 days. That is an insane frequency for a system that was engineered strictly for extreme emergencies, not for weekly wear and tear that degrades the hardware at an accelerated pace. The lethal threat to Venice does not come from the visible waves. It comes from an invisible chemical process called anaerobic mineralization of the subsoil. See, those millions of wooden piles supporting the city survived for centuries because they were buried deep in oxygen-deprived mud, meaning they could not rot. They actually petrified over time due to the minerals in the water. However, by activating the MOSE floodgates so frequently, we are drastically altering the natural flow of the lagoon currents, changing the oxygen levels in the mud. We are accidentally creating an environment where microscopic wood-eating bacteria could wake up and start devouring the hidden foundations from the inside out. It is a brutal irony. The multi-billion-dollar technology we invented to save the palaces on the surface might be accelerating the rot of the very foundations holding them up. At the end of the day, human engineering is brilliant, but nature always finds a crack to remind us who is really in charge. 2. The day the Earth forgot to be solid in Christchurch, New Zealand. Imagine walking to your refrigerator to grab a quick snack on a completely normal Tuesday afternoon at 12:51 p.m. Suddenly, the solid ground beneath your feet turns into something resembling a thick chocolate milkshake. That is not an exaggeration from a comic book movie. It is the exact reality of soil liquefaction that devastated this community back in February of 2011 following a violent magnitude 6.2 earthquake. The physics behind this are as fascinating as they are terrifying. When you have loose, sandy soil that is completely saturated with water, the dirt particles sit in a delicate balance, resting against one another. But when a violent seismic shockwave hits, that physical contact between the grains breaks down and the trapped water absorbs all the pressure. Boom! In the blink of an eye, a neighborhood filled with heavy homes and parked cars turns into a gray soup incapable of holding a single ounce of weight. Cars did not sink into cracks. They literally drowned in the middle of the street, and massive fountains of gray mud bubbled up from underground, bursting into living rooms right through the carpets. It was absolute chaos. The government had to map out a color-coded evacuation zone, creating a red zone where more than 8,000 properties were permanently demolished because the ground was deemed completely unusable. Today, those neighborhoods are nothing but empty, grassy plains. While everyone blames the groundwater and the sand, the true secret catalyst in Christchurch was the intrinsic magnetic resonance of its deep, elastic microlayers of clay. As it turns out, the shock waves did not just shake the ground. They hit a perfect frequency that matched the natural elasticity of the ancient estuary sediments buried deep beneath the city. This physical trap acted like a natural amplifier, causing the trapped energy to bounce up and down repeatedly instead of radiating out to the sides. It was that specific bouncing effect, that vibration trapped in a closed underground loop, that liquefied the soil with a destructive force 3 times greater than what engineers thought was mathematically possible for an event of that size. 1. The Great Rift Valley, East Africa. Forget the standard maps from geography class that show Africa as a solid, unyielding block of stone. The African continent is literally tearing itself apart in real time. This is not an alarmist theory or a sci-fi prediction. It is a hard fact measured down to the millimeter by high-precision satellites. They show the Earth's crust stretching between 0.24 and 0.28 inches every single year. Picture a massive 1,800-mile scar slicing down the map from the Afar Triangle in Ethiopia all the way to Mozambique. In about 5 to 10 million years, the entire eastern portion, the Somali Plate, will break off entirely, allowing the ocean to flood the void and creating a brand new sea right where lions walk today. It is wild. Back in 2005, the Earth gave us a violent preview of this process. In the Afar region, a massive crack measuring 35 miles long, 26 feet wide, and nearly 200 feet deep ripped open in just 10 days, a mere blink of an eye in geological time. You see, this valley is not just a deep trench, it is a highly complex system of faults, active volcanoes, and hot springs that shapes iconic landscapes like the Serengeti and Mount Kilimanjaro. What is happening out here is the exact same tectonic mechanism that separated Africa from South America 130 million years ago to form the Atlantic Ocean, except this time we are watching it live. Most people think the Earth just cracks open because the plates are being pulled from the outer edges, but the real engine is driving upward from below. The culprit is a massive mantle plume, a colossal superstructure of superheated rock rising from the deep interior of the planet. This thermal mass acts like a giant blowtorch blasting the base of the crust, heating it, expanding it, and making it extremely brittle. As the roof weakens from the intense heat, gravity causes the center blocks to drop, creating sunken valleys known as grabens. The magma does not just fill the empty space, it actively shoves the edges outward, working like a natural hydraulic wedge that fractures the continent from its very heart. It is a battle of planetary forces moving forward relentlessly. Which of these geological shifts surprised you the most? Drop a comment below. Remember to like, subscribe, and turn on notifications. Check out the videos on your screen to keep watching. See you next time.